Okay, we're looking great on the data. Let's see if it'll spool the turbo. Still heard some detonation, but we're within, it's in fuel control. You can hear a little turbo. Now keep in mind, it's been running like this for how long, Gabriel? Like a year?
More than a year.
More than a year. So if it's been running, you know, lean, or the engine needs to get back into its happy state. So I think more driving will do it better. So with the turbo, we should be approaching like 25 or 30 psi on the manifold pressure. 20 psi maximum. Okay, so it's building only 5 pounds of boost. We should be more than that, but check engine light's not on. Maybe some turbo code will pop up eventually when it runs that test, but at least it's happy with the oxygen sensors and the fuel trims now. So one variable here, you know, the performance is decent, but it should be a little bit better, and we have that slight detonation sound. So I asked the owner what type of fuel does he put in the car, and he said right now just regular 87 unleaded, because he tried premium and didn't make a difference. However, since the oxygen sensors are working now, so that system is fixed, I think for a turbocharged car, when you're really under boost, you want the high octane gasoline. So next tank, he'll fill the good, you know, 93 octane, and he'll let me know if the performance gets even better. Because whenever you hear that knocking, the computer will retard the ignition timing, and you'll lose some power. That's that's the way it's designed. So, all right, no fault codes stored after a 10-mile test drive. The car runs better than it has in a long time. So we're going to make that wire permanent, probably solder it to the pin of the relay and to those wires on, you know, the oxygen sensor heaters, and then lift it up, see what's clunking. All right, so let's make this wiring repair permanent. So we just want to expose some copper on these control wires, and what you want to do is get your stripping tool in there on the appropriate setting, and then just gently pull. Oh no, that took the pin out. Well, that didn't work as planned. Okay, so we're finalizing the repair. So I have one wire, and I stripped it here so I can tie into control wire number 1, and it terminates at control wire number 2. And then we'll run it down to the fuse box to the ASD relay. It's only a few inches of wire. That's going to be the repair. So let me put some solder on that. We'll tape this up and then go to the fuse box. Again, you couldn't do this repair with butt connectors. This is custom wiring modification, and easy enough to restore to factory spec if the owner ever replaces the engine computer. So make sure that solder fuses to both wires. Heat that up. Okay. Solid. Is that what Alex at Northridge Fix says? Alright, step 2. Let's solder the wire to that leg of the relay. And we should be all done. to be a nice, neat, uh-oh, jumped off, modification here. So we don't want to take up too much of the leg itself. Just want to fuse the wire to there we go. That's perfect. Now we just pop this thing in. Okay, and then I did modify the OEM fuse box cover a little bit so that wire can escape. And thing of beauty. That's it. We're done. There's our bypass wire. So the car will be running happy. So for the suspension, I can't find anything that's making a loud clunking noise going over bumps. I mean, you got your classic sway bar, nice and tight. The owner said he replaced the bushings, he replaced everything. He replaced the power steering rack. By the way, there is a boot torn on the rack. That's not good. But the subframe to the frame is tight. The engine mounts all look fine. He's replaced those. Control arms, he's replaced those. Bushings are fine. There's no metal to metal beading. So that's a mystery.
Yeah, yes.
So the clunking noise actually goes away when you touch the brakes. What about when you're speeding up? So if I'm on the gas, less noise. Coasting is the worst. Brake, no noise, right? It's like a switch. Okay, we have something to work with then. Alright, final diagnosis on this PT Cruiser is the horrible clunking sound. It sounds like it's coming from under your feet, and it only happens when you're just coasting. When you're on the brakes, it disappears, and when you're on the gas, it also disappears. Forward, reverse, no sound until you're just coasting on the gravel, and then it's brrr, it just, you know, hammers your feet. So just based on those symptoms, it has to be something in the front end suspension. It can't be brake calipers. So either control arms or struts, and the sound is coming from the floor area. So focus on these control arms. So this lower bushing right here, it looks fine until in the relaxed state, there it is. It's just bouncing up and down. It's causing all the racket, that bushing right there, and that's part of the control arm. It's a Moog unit, it's 4 years old, so that's it. That's what needs to be replaced. I think that's it. So owner will keep me updated on the fuel economy and the power. He'll fill it up with premium gas on his way home to New York City. That was really neat. Did not expect to fix this car with a 4-inch piece of wire. To fix it the right way, you need a replacement computer. But if this works, no check engine light, drives perfect, I think that's a perfect solution. So thanks a lot for watching, and we'll see you on the next one. Bye bye. Well, the customer was ready to leave, and he said, "Hey, I have the check engine lights back on." Uh-oh, instant comeback. 2 codes stored. Now we have a P0032 heater control circuit high bank 1 sensor 1 and a 3.8 high bank 1 sensor 2. Before it was low. Okay, we have the bypass in there, obviously. So I guess it ran the check and did not like the results. So my question is, will it force it into open loop? Let's look at the live data. Obviously save that in a report. Dang it. You can hear that, how the engine's changing RPM when it goes into open loop drive. Look, flatlined. Well, that's unfortunate. We put a resistor in there to lower that voltage a little bit, but I think the PCM is too smart, and it's, you know, commanding a pulse width modulated signal, not just a steady voltage. So like I said, that was a neat experiment. It worked for a couple test drives. I'm wondering if you clear the codes and, you know, re-enable it. So let's clear the codes out. The owner just have to drive with a little Bluetooth dongle and clear his codes every time, maybe. Codes have been cleared. Okay, turn key off. And read the live data, see if we're in closed loop. Totally happy. Totally happy. And I guess whenever the criteria is to run that oxygen sensor heater test, it will fail. So kind of a partial win. We'll trick the computer a little bit, but not 100%. So right now, if you read the fault code, I'm sure it'll say no codes. Yep, no codes this ignition cycle. This is crazy. I just put in a 1 amp test light instead of a straight fuse jumper from the ASD to those two control wires. And now it's not setting any more codes. You can see the light is not lit. So the driver is doing something. Somehow it's putting out positive voltage. We have positive voltage here. And when that filament, you know, barely flickers, that means some current is passing through the test lights. Not full current like it was before. They're not stuck low. It's blowing my mind. How did that come back to life? So if you turn the key off, you see the test light lights up and then the ASD turns off. On the prime cycle, before we had 2 seconds of light bulb and then it was off. Now it doesn't even light up because the computer's also, somehow the driver came back to life and is now feeding 12 volts to the oxygen sensors. No more check engine light, no codes. It goes back to closed loop. Right about now. There we go, closed loop. So I guess we're gonna have to install a light bulb in series on that power wire to trick this engine computer. What if we remove the light bulb? Will it set the circuit low code? Let's try that. Okay, test light's out of the picture. So the wire's cut. So we're almost back to stock, but the two heater drivers are actually tied together now with that jumper wire. I didn't cut that yet. So we just have a voltmeter on the output of the computer going to the heaters. I want to see if this driver's, one or two drivers came back to life. So, key on, 10 millivolts, and nothing. 200 millivolts. I'm sure the check engine light's on, and I'm sure we're going to be in open loop, and I'm sure we're going to set the original 0031-P0037 trouble codes. Let's just double check. So this computer's not fixed. We're back to 31 and 37. So it's not happy with stock. It's not happy with a direct jumper from the ASD, but through a light bulb it seems to be happy. That completely blows my mind. But let's install a permanent light bulb in there. Like a 1 amp apparently is enough. I don't know what to say. So I'm trying out a few different amperages here. We just have one bulb, a half an amp, and now it's brightly lit. And no fault code stored, but in live data these oxygen sensors are not heating up. If you look at fuel system status and then trims and oxygen sensors, 1.275 open loop. Let's add some amperage. Alright, now I switched, still one bulb, but it's on the 2 amp filament. Let's see. Huh. So it didn't light up. When you turn the key off, okay, it's doing its little pulse. Now let's look at the live data again. Look, upstream sensor is heating right up. Closed loop. It's happy. So a standard 2 amp bulb is what is going to fix this car. So we just have to solder it in, tape it up. I think that's the final solution here. And just make sure we didn't set any pending codes. You know, put it in reverse like the owner did. Make sure it's not going to spaz out. Man, this car is picky, but we're stubborn. And if this repair works, do you know how many PCMs can be saved from just throwing them away? Or sending them to like flagship 1 or something? No fault code. It's happy. Let's wire in that bulb. Alright, so got a 3057 bulb soldered in on the brake filament, so 2 amps. I'm going to wrap this up really well so we don't stress these joints and secure it. And run the car, hopefully it'll be happy. Alright, with the 2 amp bulb, you can see the feed to the heaters is fluctuating. We're in closed loop, the car is happy. And what is the bulb doing? It's doing this. That blows my mind. How can that driver come back to life when there's some voltage fed to that circuit? It's totally happy now. That's pretty neat.